A point mass m is constrained to move on the inner surface of a paraboloid of revolution x square plus y square equal to az, where a greater than 0 is a constant. When it spirals down the surface under the influence of gravity along minus z direction, the angular speed about the z axis is proportional to. Four options are given: A independent of z, B z, C z raised to minus 1 and D z raised to minus 2. Here a point mass m is constrained to move on the inner surface of a paraboloid of revolution and it spirals down the surface along minus z direction. Let the coordinate of the mass be xyz. It is spiraling down along the minus z direction and finally it arrives at the bottom. To solve this problem, use an appropriate coordinate system. Here, choose the cylindrical polar coordinate system. X is equal to r cos theta, y is equal to r sin theta, z equal to z. But in the question, it is given that x square plus y square equal to a z, from which we get z equal to x square plus y square by a, which is equal to r square by a. Now what is the Lagrangian? L is equal to kinetic energy minus potential energy. Kinetic energy is given by half m into r dot square plus r square theta dot square plus z dot square. Now we can write it as half m into r dot square plus r square theta dot square plus z dot square. What is z dot? Z dot is 2r r dot by a. Therefore, our Lagrangian becomes L is equal to t minus v, which is equal to half m into r dot square plus r square theta dot square plus 2r r dot by a whole square minus mg z. Again, substitute the value of z, that is equal to r square by a, so that your Lagrangian look like half m r dot square plus r square theta dot square plus 2r r dot by a whole square minus mg r square by a. This is the Lagrangian. Now if you look the Lagrangian, you can see that the coordinate theta is missing in the Lagrangian. The coordinate theta is missing in the Lagrangian, or we can say theta is the cyclic coordinate here. The coordinate theta is missing in Lagrangian, or theta, we can say theta is the cyclic coordinate here. When a coordinate is cyclic, then we have studied that the corresponding conjugate momentum is constant. When theta is cyclic, then p theta or j, which is the angular momentum, which is a constant. Now p theta is nothing but dou L by dou theta dot. Now what is dou L by dou theta dot, which is mr square theta dot, that is equal to constant, or theta dot become proportional to 1 by r square. Now from the equation of z, we have r square is equal to az. Now we can say that this theta dot is proportional to 1 by az, or theta dot is proportional to 1 by z, since a is a constant. Now what is theta dot? Theta dot is the angular speed. Theta dot is the angular speed. Therefore, we can say that the angular speed about the z axis, theta dot, is proportional to 1 by z. Or theta dot is proportional to z raised to minus 1. Therefore, among the options given, option C is the right answer.